The universe, in all its vastness, has been a subject of wonder, awe, and bewilderment for humanity since the dawn of time. From the moment we first gazed up at the stars, our ancestors were struck by the sheer immensity and complexity of the cosmos. The endless expanse of the sky, the unfathomable size of the universe, and the intricate interconnections between the forces of nature all created a sense of wonder and, at times, fear. The universe is a chaotic system, constantly in motion, governed by forces that often seem beyond comprehension. It is a world full of unpredictability, where matter and energy swirl together in patterns too complex for us to fully grasp. Yet, within this apparent chaos, there lies a deeper sense of order, an underlying structure that governs the motions of planets, stars, galaxies, and even the very building blocks of life. The very nature of the universe seems to be built upon paradoxes. It is both chaotic and ordered, unpredictable and systematic, random and determined. These contradictions raise an intriguing question. How do we make sense of a universe that is seemingly so unpredictable and chaotic? How do we navigate a world that appears to be full of randomness, only to find that beneath the surface there are laws and patterns that guide its behavior? This is the essence of the human pursuit, to find order in the chaos of the universe. For centuries, human beings have strived to impose order on the world around them. From the earliest civilizations, we sought to understand the natural forces that shape our world. Ancient astronomers, for example, observed the regular movements of celestial bodies and began to see patterns in their paths. They used these observations to create calendars and predict the changing seasons. This was the first step toward understanding the chaotic universe in a more orderly fashion. As time progressed, early philosophers and scientists, such as Pythagoras and Aristotle, sought to explain the world in terms of logical principles and natural laws. They believed that the universe was not a random collection of events, but rather a system governed by rational and understandable rules. These early efforts laid the groundwork for what would become the scientific method, a systematic approach to understanding the world. However, the quest for order in the universe is not merely an intellectual pursuit. It is deeply embedded in the human psyche. From the very beginning of life, we are conditioned to seek patterns and predictability. The human brain is an extraordinary organ, capable of processing vast amounts of information and finding patterns within it. From infancy, we begin to make sense of the world through repetition and consistency. We learn to recognize faces, objects, and even sounds, and we begin to associate these elements with specific outcomes. This ability to recognize patterns is essential for survival, as it allows us to predict and navigate our environment. As we grow, we continue to seek order in the chaos of the world, whether it's through language, social structures, or the systems we create to manage our daily lives. At its core, the human mind is wired to seek structure. This instinct is so deeply ingrained in us that we find it difficult to function without it. Whether it's the rhythm of our daily routines, the orderliness of our surroundings, or the logical structure of our thoughts, we crave consistency. Without this order, life can feel overwhelming and disorienting. The very act of creating order in our environment through organization, planning, and systematization provides a sense of stability and security. When we face chaos, whether it's in our personal lives or in the wider world, we instinctively seek ways to bring things back into balance. This desire for order is not just an intellectual preference, it is a psychological need, one that shapes our thoughts, behaviors, and actions. This drive to find order is evident in many aspects of human life. In science, for example, our quest to understand the universe is based on the assumption that there is a hidden order beneath the apparent randomness of nature. Early scientists such as Isaac Newton believed that the universe operated according to fixed laws of motion and gravity. These laws, they believed, were universally applicable and could explain the movement of all objects in the universe, from the smallest particles to the largest celestial bodies. Newton's discovery of the laws of motion and gravity was a groundbreaking achievement in the history of science, as it provided a framework through which we could understand the physical world. For centuries, his laws were considered the ultimate explanation for how the universe worked. However, as our understanding of the universe deepened, it became clear that the laws of classical mechanics, while incredibly powerful, were not sufficient to explain every phenomenon. The universe, it seemed, was far more complex than anyone had imagined. In the early 20th century, scientists like Albert Einstein and Niels Bohr began to challenge the classical view of the universe. Einstein's theory of relativity, for example, revealed that space and time were not fixed, but rather fluid and dynamic. Similarly, the discovery of quantum mechanics unveiled a world where particles behaved in strange and unpredictable ways. At the subatomic level, the very idea of order seemed to break down, as particles could exist in multiple states at once, and their behavior could not be predicted with certainty. The universe, it seemed, was far more chaotic than we had ever imagined. This realization, however, did not mark the end of our quest for order. Instead, it sparked a new wave of exploration and discovery. Scientists began to develop new theories and models to explain the strange and seemingly chaotic behavior of the subatomic world. The advent of quantum mechanics, for instance, did not negate the search for order, but rather expanded it into new realms of understanding. Quantum theory introduced the idea that, while we may not be able to predict the exact behavior of individual particles, there are still underlying patterns and probabilities that govern their behavior. In this sense, even the chaos of the quantum world was found to be governed by order, albeit a different kind of order than what we had previously understood. The search for order in the chaotic universe is not limited to the scientific realm. It also plays a crucial role in our daily lives. In the face of uncertainty and unpredictability, we create systems and structures to help us make sense of the world. From the organization of societies to the development of legal systems, we impose rules and regulations to bring order to our interactions with others. We create institutions, governments, schools, and businesses that provide structure and predictability to our social lives. These institutions are not just practical tools for managing society, they are also psychological constructs that help us navigate the complexity of human existence. In many ways, the need for order is a fundamental aspect of the human experience. It is not just a desire for intellectual understanding, but also a deep psychological need for stability and predictability. In a world that often seems chaotic and beyond our control, the search for order provides us with a sense of meaning and purpose. It gives us a framework within which we can navigate the complexities of life, from the personal to the cosmic. Yet, even as we strive to create order in the universe, we must also acknowledge the limitations of our understanding. The more we learn, the more we realize how little we truly know. The universe is vast, and its mysteries are far from being fully unraveled. We may never fully understand the underlying order of the cosmos, but that does not diminish the value of our search. It is in the very act of seeking order, of striving to make sense of the chaos, that we find meaning and purpose in our lives. The quest for understanding, for finding structure in the randomness of the universe, is an essential part of what it means to be human. As we continue to explore the universe, we may uncover new patterns and discover new laws that govern the cosmos. We may find that the order we seek is even more complex and elusive than we had imagined. But in the process, we will also gain a deeper appreciation for the chaos itself, the unpredictability and randomness that make the universe so remarkable. The tension between order and chaos, structure and randomness, is what drives our exploration and fuels our curiosity. It is what propels us forward as we continue to search for meaning in a universe that is, at its core, both chaotic and ordered. And so, the pursuit of order in a chaotic universe remains one of humanity's greatest challenges. It is a journey that requires both intellectual rigor and psychological resilience as we navigate the complexities of the world around us. Yet, it is also a journey that brings us closer to understanding not only the universe itself but our place within it. Whether through science, philosophy, or daily life, the search for order is an enduring part of the human experience, one that will continue to shape our future and our understanding of the cosmos. As we continue our exploration of the chaotic nature of the universe, we must also acknowledge the various ways in which our understanding has evolved over time. Humanity has never been content to simply accept the universe as a chaotic, meaningless expanse. Instead, we have continuously sought to uncover patterns, to find structure within the randomness, and to create systems that allow us to navigate the complexities of existence. This drive for order is not only an intellectual pursuit, but an intrinsic part of human psychology, deeply embedded in the fabric of our cognition. From the very beginning of recorded history, humans have looked to the heavens and the earth with a sense of wonder and curiosity. The ancient civilizations were the first to begin the process of ordering the cosmos. Observing the movements of the sun, moon, and stars, early astronomers noticed patterns and cycles in the heavens. They created calendars based on these celestial movements, enabling them to predict the changing seasons, plan agricultural activities, and track the passage of time. This was one of humanity's earliest attempts to impose order on the seemingly unpredictable universe. The observation of the night sky became a symbol of the broader human desire to understand the unknown. This early fascination with celestial order eventually gave rise to some of the most significant breakthroughs in the history of science. Greek philosophers, such as Pythagoras and Aristotle, sought to explain the nature of the universe by using logic and reason. Pythagoras, for instance, famously believed that the universe could be understood through mathematics, specifically through the ratios of numbers and the harmonious proportions they found in nature. Aristotle, on the other hand, believed that the universe operated according to a set of natural laws that could be deduced through observation and reason. While many of their ideas were eventually proven to be inaccurate, their intellectual efforts laid the groundwork for future generations of scientists who would seek a deeper understanding of the universe. By the time of the Renaissance, humanity's understanding of the universe had expanded dramatically. Figures such as Nicolaus Copernicus and Johannes Kepler challenged the ancient geocentric model of the universe, suggesting that the Earth was not at the center of the cosmos but rather orbited the Sunday. Kepler, through careful observations, discovered that the planets followed elliptical orbits around the Sunday. This was a critical breakthrough in understanding the motion of celestial bodies. In doing so, he revealed a deeper level of order in the universe than previously thought possible. These discoveries marked the beginning of modern astronomy and the birth of the scientific revolution, a period that would see the systematic application of reason and empirical observation to unlock the mysteries of the natural world. Yet, even as scientific discoveries revealed new layers of order in the universe, they also uncovered deeper complexities. The laws of physics, as developed by Isaac Newton in the 17th century, seemed to offer a definitive explanation of how the universe worked. Newton's laws of motion and his law of universal gravitation provided a comprehensive framework for understanding the behavior of objects in the universe. Newton's laws suggested a universe governed by predictable forces that could be quantified and described mathematically. For centuries, this view of the universe reigned supreme, as it too appeared to offer a complete and rational explanation for the behavior of matter in the cosmos. However, As the 19th and 20th centuries unfolded, new discoveries began to challenge the certainty of this mechanistic view of the universe. The advent of quantum mechanics and the theory of relativity shattered the simple, deterministic view of the cosmos. Albert Einstein's theory of relativity, which described how space and time were intertwined and relative to the observer, revealed that our understanding of the universe was far more fluid and complex than previously imagined. The theory of relativity demonstrated that time, space, and gravity were not separate entities but part of a unified fabric that could be warped and stretched by massive objects like stars and planets. This marked a profound shift in our conception of the universe, as it showed that even seemingly immutable forces like gravity could not be understood in isolation. Instead, they were part of a dynamic, interconnected system that was constantly changing. Even more disorienting was the rise of quantum mechanics, which introduced a level of uncertainty into the very fabric of reality. Quantum theory posited that at the subatomic level, particles did not behave in predictable ways. Instead, their behavior could only be described in terms of probabilities. This was a dramatic departure from the deterministic laws of classical mechanics. In the quantum world, particles could exist in multiple states at once, and their positions and velocities could only be known with a certain degree of uncertainty. This uncertainty, known as Heisenberg's uncertainty principle, challenged the notion of a fully ordered and predictable universe. In a quantum universe, the boundaries between order and chaos became blurred, and the universe appeared to be governed by probabilistic rather than deterministic laws. These revolutionary discoveries in physics underscored a central truth about the nature of the universe. Chaos and order are not opposites, but rather two sides of the same coin. The universe, it seems, is a paradox at once chaotic and ordered, random and structured. It is a place where seemingly unpredictable events unfold within an overarching system of natural laws. The tension between order and chaos is at the heart of human inquiry. As much as we may yearn for certainty and predictability, we must also confront the fact that the universe is a complex and mysterious place, filled with uncertainty and paradox. At the same time, the recognition that the universe is both chaotic and ordered does not mean that the human quest for understanding is in vain. On the contrary, it is precisely because the universe is so complex and multifaceted that our efforts to understand it are so meaningful. The scientific method, with its emphasis on observation, experimentation, and rational inquiry, has allowed us to uncover remarkable insights into the workings of the cosmos. While we may never fully understand the true nature of reality, the pursuit of knowledge continues to expand the boundaries of our understanding. Science, philosophy, and mathematics are all tools that we use to navigate the complex interplay between order and chaos. This search for order in the chaotic universe is not only an intellectual endeavor, but also a deeply psychological one. As humans, we are inherently driven to seek meaning in a world that often appears random and uncertain. Our minds are wired to search for patterns and to impose structure on the world around us. This drive for order is a reflection of our desire for control, security, and stability. In a world that can often seem chaotic and unpredictable, the quest for order provides us with a sense of purpose and direction. Yet, as we continue to explore the universe and uncover its secrets, we must also embrace the chaos that lies at the heart of existence, for it is in the very uncertainty and unpredictability of the universe that we find the potential for creativity, growth, and discovery. The tension between order and chaos is what propels us forward in our quest for knowledge and understanding. As we continue to push the boundaries of human inquiry, we must remain open to the possibility that the universe is far more complex and mysterious than we could ever imagine. It is this uncertainty, this unpredictability, that makes the universe so fascinating, so inspiring, and so full of possibility. The interplay between order and chaos, structure and randomness, is what defines the universe and our place within it. As we continue to seek understanding, we must remember that it is not the certainty of the answers that drives us forward, but the mystery of the questions. It is the tension between order and chaos that gives life its richness, its depth, and its beauty. Whether in the realms of science, philosophy, or daily life, the quest to understand the universe is an ongoing journey, one that will continue to shape the way we see the world and our place in it for generations to come. The human mind has always been driven by a powerful need to make sense of the universe. This need arises from the belief that the universe itself, in all its complexity, is not an incomprehensible, chaotic place, but rather a system governed by patterns, laws, and order. From the earliest times, humans have looked to the stars, the seasons, the behavior of animals, and the forces of nature to understand how things work. These early observations laid the foundation for what would become one of humanity's most fundamental pursuits, the search for order within the chaos of the universe. As the centuries passed, this drive to understand the natural world evolved from mere curiosity into a more formalized, intellectual pursuit. Early astronomers, such as the Babylonians and Egyptians, created detailed astronomical charts and calendars, using the stars as their guides. They observed that celestial bodies moved in regular, predictable patterns, which allowed them to track time and organize their lives. These early observations were, in many ways, humanity's first attempt to impose order on the universe. By observing the natural world and identifying the patterns within it, these ancient civilizations sought to create a sense of stability and predictability in their lives. This drive for order is not simply an intellectual pursuit, it is deeply psychological. The human mind is inherently wired to seek patterns. From a young age, children begin to recognize patterns in their environment, whether it's the faces of their caregivers, the sounds of language, or the rhythm of daily routines. This ability to identify patterns is not just a tool for understanding the world, it is essential for survival. Recognizing patterns in the environment allows humans to predict outcomes, make informed decisions, and navigate the complexities of the world around them. The human brain is designed to look for regularities and structure in the chaos of life, to impose some form of order onto the vast and often overwhelming world. As civilizations progressed, the intellectual pursuit of order expanded into the realms of mathematics, philosophy, and science. Ancient Greek philosophers such as Pythagoras and Plato were among the first to seriously consider the idea that the universe was governed by inherent, logical principles. Pythagoras, for instance, argued that numbers were the key to understanding the natural world. He believed that the universe could be understood through mathematical relationships and proportions, with harmony being the underlying order of all things. Plato, too, saw the universe as a realm governed by ideal forms, abstract principles that existed beyond the physical world but shaped the reality humans experienced. These early philosophical ideas about the order of the universe set the stage for the later development of scientific thought. As the Renaissance unfolded, figures like Copernicus and Galileo began to apply empirical methods to study the heavens, pushing back against centuries of religious dogma that had placed the Earth at the center of the universe. Galileo's observations of the moons of Jupiter, Copernicus' heliocentric theory, and Kepler's laws of planetary motion were revolutionary in that they provided a new framework for understanding the order of the cosmos. Instead of relying on ancient myths or religious explanations, these thinkers used observation, experimentation, and mathematics to reveal that the universe was not a chaotic, unknowable expanse, but a structured system that operated according to predictable laws. As the scientific revolution continued into the modern era, Isaac Newton's laws of motion and gravitation became the pinnacle of humanity's search for order. Newton's work provided a comprehensive framework for understanding the motion of celestial bodies, the behavior of objects on Earth, and the forces that govern them. For the first time, humanity had a unified theory that could explain the motion of planets, the fall of an apple, and the orbit of the moon with a single set of laws. Newton's laws brought order to what had previously been seen as a chaotic and unpredictable universe. However, as humanity's understanding of the universe deepened, it became clear that the simple, deterministic view of the world that Newton had presented was not enough to explain all of nature's complexities. The 19th and 20th centuries brought about a series of discoveries that challenged the idea of a purely ordered, predictable universe. The advent of quantum mechanics and the theory of relativity revealed a world far more complex than anyone had anticipated. Albert Einstein's theory of relativity showed that space and time were not fixed, as Newton had suggested, but rather fluid and relative to the observer. Similarly, the discovery of quantum mechanics revealed that, at the subatomic level, particles behaved in unpredictable and probabilistic ways. These discoveries suggested that the universe, far from being a simple, mechanical system, was filled with uncertainty, randomness, and complexity. Yet, even in the face of these challenges, the search for order did not end. Instead, scientists began to grapple with the question of how to reconcile the apparent chaos of the quantum world with the orderliness of classical physics. Quantum theory, for example, did not completely abandon the search for patterns. Rather, it suggested that while we may not be able to predict the exact behavior of individual particles, we can still identify probabilistic patterns that govern their behavior. In other words, while the subatomic world may seem chaotic, it is still governed by underlying principles that can be described statistically. This idea of probabilistic order, rather than deterministic order, marked a significant shift in our understanding of the universe. The tension between chaos and order continues to be one of the central themes in modern science and philosophy. As our understanding of the universe continues to evolve, we find that the search for order is far from over. Rather than rejecting chaos, many scientists and thinkers have come to embrace it as an essential part of the cosmos. The very unpredictability of the universe, they argue, is what makes it so rich with possibility and creativity. In this view, the chaos of the universe is not something to be feared or rejected, but something to be understood and integrated into our broader understanding of reality. The human mind's desire for order, however, is not limited to the intellectual sphere. It also plays a crucial role in our psychological well-being. In a world that often seems chaotic and unpredictable, the human mind seeks out stability and predictability. This is evident in the routines we establish, the structures we create in our societies, and the telos to do systems we build to organize our lives. Order brings a sense of control, security, and understanding. Without order, the world can seem overwhelming and disorienting. However, while order provides structure and stability, it is often in the chaos that we find the greatest opportunities for growth and discovery. The need for order is perhaps most apparent in our everyday lives. Whether it is the daily rhythms of waking up, going to work, eating meals, or sleeping, humans are creatures of habit. These routines provide a sense of continuity and stability, allowing us to navigate the complexities of life. Similarly, societies are built on systems of laws, rules, and norms that create order in the social world. These systems ensure that individuals can coexist in a predictable and organized way, reducing the uncertainty that comes with living in a complex, interconnected world. But just as we seek order in our personal lives, we must also embrace the chaos that exists within the world. It is through the unpredictable and often chaotic elements of life that we find the potential for creativity, innovation, and personal growth. The tension between order and chaos, structure and unpredictability, is what gives life its richness and depth. It is in the moments of uncertainty that we often experience the most profound breakthroughs, whether in science, art, or personal transformation. The chaos of the universe may be disorienting, but it is also a source of endless possibility, and it is this tension that drives us to explore, learn, and grow. As we continue to seek order in a chaotic universe, we must recognize that the search for meaning and structure is an ongoing journey. While we may never fully understand the universe, the pursuit of order is what fuels our curiosity, shapes our intellect, and helps us make sense of the world around us. The universe, in all its complexity, may remain mysterious, but it is through our efforts to impose order on its chaos that we find purpose, meaning, and a deeper connection to the world. Whether through science, philosophy, or personal experience, the quest for order in a chaotic universe is one of humanity's greatest endeavors, one that will continue to shape our understanding of the world and our place within it. As the search for order in a chaotic universe continues, one of the greatest challenges humanity faces is reconciling the apparent randomness of the cosmos with the human need for structure. It is a search that spans not only the intellectual domain of science and philosophy, but also deeply impacts our psychological and emotional experiences. Throughout history, thinkers, scientists, and even ordinary individuals have attempted to make sense of a world that often seems unpredictable and filled with chaos. Yet, despite the vastness and complexity of the universe, there is a persistent belief that beneath the seeming randomness, there exists a deeper, more profound order waiting to be uncovered. This desire for understanding is not simply born out of intellectual curiosity, but out of necessity. As humans, we are creatures of pattern seeking. Our brains are constantly on the lookout for regularities and consistencies that allow us to navigate the world with more certainty and predictability. It is this inherent desire to make sense of the world that has led to scientific discoveries, technological innovations, and the creation of social structures that provide stability and order. From the creation of laws governing societies to the development of scientific theories that explain the behavior of the natural world, humans have continually sought ways to bring structure to their environments. In the context of the universe, one of the most profound realizations of modern science is that the search for order is not simply an intellectual exercise, but a reflection of a deeper, more intrinsic aspect of our existence. The universe, for all its apparent chaos, is not entirely without structure. The vastness of space, the complexities of biology, and the intricate relationships between matter and energy all point to a level of organization that we are only beginning to comprehend. Yet, at the same time, the unpredictable nature of the cosmos reminds us that our understanding is still limited and that true certainty may forever remain out of reach. One of the most groundbreaking shifts in our understanding of the universe came with the development of quantum mechanics in the early 20th century. Before the advent of quantum theory, the universe was largely understood through the lens of classical physics, where Newton's laws of motion and gravity provided a framework for understanding everything from the fall of an apple to the motion of planets. Classical physics suggested a deterministic universe, one where, if we knew the initial conditions of a system, we could predict its future behavior with absolute certainty. However, the development of quantum mechanics revealed a radically different picture. At the quantum level, particles behaved in ways that were unpredictable, existing in multiple states at once, and their properties could only be described in terms of probabilities rather than certainties. This introduced a new concept into our understanding of the universe: uncertainty. Rather than a universe that could be fully understood through precise measurement and prediction, the quantum world suggested that randomness and unpredictability were fundamental aspects of nature. The very act of observing a quantum system could alter its behavior, a phenomenon known as the observer effect. This was a stark contrast to the deterministic view of the universe that had dominated scientific thought for centuries. The realization that the universe operates on a probabilistic rather than deterministic framework has profound implications for our understanding of order. While it may seem that randomness reigns at the quantum level, scientists have discovered that there are still underlying principles and patterns that govern the behavior of particles. The seemingly chaotic nature of quantum mechanics is, in fact, governed by probabilistic laws that allow us to make sense of the apparent randomness. Yet, the uncertainty introduced by quantum mechanics does not negate the search for order, but rather expands it into new realms of understanding. Scientists have come to recognize that the universe, at both the macroscopic and microscopic levels, operates according to principles that can be understood, even if not fully predicted with certainty. Just as Newton's laws of motion were once the bedrock of our understanding of the physical world, quantum mechanics has introduced new laws and principles that describe the behavior of particles and energy at the smallest scales. These laws, though probabilistic in nature, provide a framework through which we can understand the behavior of the subatomic world. In this way, even within the seemingly chaotic realm of quantum mechanics, there is still an underlying order waiting to be discovered. The search for order in a chaotic universe is not limited to the realm of physics. Philosophers, too, have grappled with the tension between order and chaos. From the ancient Greeks to modern-day thinkers, the relationship between structure and randomness has been a central theme in philosophical inquiry. Philosophers like Plato believed that the universe was governed by ideal forms, abstract, perfect concepts that existed beyond the physical world and served as the foundation for all reality. For Plato, the search for order was a quest to understand these ideal forms and their relationship to the material world. Similarly, Aristotle sought to uncover the natural laws that governed the behavior of the universe, believing that reason and observation could reveal the underlying order of the cosmos. In more recent times, the philosopher Friedrich Nietzsche introduced a radically different view of the universe, one that embraced chaos as an essential force of creation. Nietzsche argued that order and chaos were not opposites but complementary forces that gave rise to one another. In his view, it was the very tension between chaos and order that drove the creative potential of the universe. Nietzsche's concept of the will to power suggested that the human drive for mastery and control was a reflection of our desire to impose order on a chaotic world. Yet it was also through this struggle that individuals could transcend the limitations of their circumstances and reach new levels of understanding and existence. These philosophical perspectives highlight the deep and complex relationship between order and chaos in our understanding of the universe. Whether through science, philosophy, or personal experience, the search for meaning and structure is an intrinsic part of the human condition. In a world that often seems unpredictable and beyond our control, the desire to find order is a natural response, a way to create a sense of security and purpose in the face of uncertainty. But as the examples from quantum mechanics and philosophy show, the search for order is not simply about eliminating chaos, but about learning to navigate the tension between the two. This tension between order and chaos also plays a crucial role in our psychological well-being. On a personal level, the need for order is fundamental to our ability to function in the world. Humans are creatures of habit, and the routines and structures we create provide a sense of stability and control. From the organization of our homes and workplaces to the laws and norms that govern our societies, we seek to impose order on the world around us to reduce the anxiety that comes with uncertainty. However, it is not just the presence of order that allows us to thrive, it is also our ability to embrace the chaos that leads to personal growth and transformation. The moments of uncertainty, the times when life feels unpredictable and chaotic, are often the moments that challenge us to rethink our assumptions, push beyond our comfort zones, and grow as individuals. This balance between order and chaos is not just a philosophical or intellectual concept, but a lived reality. From the small-scale routines of daily life to the larger existential questions we face, the quest for order in a chaotic universe is a constant and evolving process. It is a search that drives our intellectual endeavors, informs our social structures, and shapes our personal journeys. The tension between these forces gives life its richness, its complexity, and its potential for growth. In embracing both order and chaos, we find the possibility for creativity, discovery, and transformation. Whether in the realm of science, philosophy, or personal experience, the search for meaning and structure in a chaotic universe remains one of humanity's greatest endeavors, one that will continue to shape our understanding of the world and our place within it for generations to come. The search for order in a chaotic universe has been a fundamental part of human existence for centuries. Our quest to understand the forces that govern the universe, to find patterns in the apparent randomness of life, and to bring structure to a world that often seems unpredictable and uncontrollable, is a pursuit that defines much of human intellectual history. The tension between order and chaos is not simply an academic question, but one that shapes our very existence. It touches on everything from the way we understand the natural world to the systems of organization we create in our societies. This quest for understanding is rooted deeply in the human psyche, reflecting a psychological need for stability and meaning in a world that often feels chaotic. In the early days of civilization, humanity's first attempts to understand the world were based on observation and experience. Ancient cultures, particularly those involved in agriculture, began noticing patterns in nature that seemed to suggest order. They observed the changing seasons, the movement of celestial bodies, and the rhythms of nature, and used these observations to create systems to predict events. This was humanity's first attempt to impose order on what appeared to be a disordered world. Ancient astronomers, for instance, charted the positions of the stars and the movements of planets, realizing that these celestial bodies followed certain paths in the sky. By understanding these patterns, they could predict the best times for planting crops, the timing of eclipses, and the changing of seasons. However, this early search for order was limited by the tools and methods available to early humans. While they could observe the patterns in nature, they could not explain why these patterns existed or how they fit into a larger framework of understanding. The scientific revolution, which began in the 16th century, was the turning point that shifted humanity's approach from mere observation to systematic investigation. Figures like Copernicus, Galileo, and Kepler made groundbreaking discoveries about the motion of celestial bodies, demonstrating that the universe operated according to predictable laws. Copernicus's heliocentric theory, which proposed that the Earth and other planets revolved around the Sun, challenged the centuries-old geocentric model and marked the beginning of a new way of thinking about the universe. Galileo's use of the telescope allowed him to observe the moons of Jupiter, proving that not all celestial bodies revolved around the Earth. Kepler's laws of planetary motion demonstrated that the planets moved in elliptical orbits rather than perfect circles, providing a more accurate description of their motion. These early scientific breakthroughs paved the way for Isaac Newton's laws of motion and gravity. Newton's laws, which described how objects move and interact, became the foundation of classical physics and provided a unified framework for understanding the physical world. Newton's work suggested that the universe was governed by fixed, predictable laws. For example, the law of universal gravitation explained how objects of different masses are attracted to one another, and the three laws of motion described how objects behave when forces are applied to them. These laws, which could be applied universally, gave humanity a powerful tool for understanding the world. The universe, it seemed, was an ordered system governed by natural laws, and through reason and observation, humanity could uncover those laws. But as humanity's understanding of the universe deepened, it became apparent that Newtonian physics, while groundbreaking, was not sufficient to explain all phenomena. In the 19th and 20th centuries, the development of new scientific theories introduced a new complexity to our understanding of the universe. The theory of relativity, developed by Albert Einstein, revolutionized our understanding of space, time, and gravity. Einstein's theory suggested that space and time were not fixed entities, as Newton had proposed, but rather were flexible and could be influenced by massive objects like stars and planets. This theory also introduced the concept of the curvature of space-time, which helped to explain how gravity works in a more comprehensive way than Newton's laws could. For example, while Newton's laws describe gravity as a force that acts between two objects, Einstein's theory suggested that gravity is the result of the warping of spacetime around massive objects. At the same time, the development of quantum mechanics further complicated the picture. Quantum mechanics describes the behavior of particles at the smallest scales, where the classical laws of physics no longer apply. One of the most significant aspects of quantum theory is the concept of uncertainty. According to Heisenberg's uncertainty principle, it is impossible to simultaneously know the exact position and momentum of a particle. This introduced an element of randomness into our understanding of the universe, as it suggested that, at the subatomic level, particles do not behave in predictable ways. This uncertainty posed a direct challenge to the deterministic view of the universe that had dominated science since the time of Newton. The advent of quantum mechanics fundamentally altered our perception of the universe. While classical physics offered a deterministic view, in which every event could be predicted with certainty if the initial conditions were known, quantum mechanics introduced a probabilistic approach. Instead of being able to predict with certainty the behavior of particles, scientists could only calculate the likelihood of a particular outcome. This realization sparked a paradigm shift in how we view the universe. It was no longer a predictable machine operating under fixed laws, but a complex system that incorporated uncertainty and randomness at its core. Despite these developments, the search for order did not end with the discovery of uncertainty. If anything, it deepened humanity's resolve to understand the underlying principles that govern the universe. The fact that the universe operates according to both predictable laws, as described by classical mechanics, and probabilistic patterns, as described by quantum mechanics, suggests that order and chaos are not mutually exclusive, but are inextricably linked. The duality of order and chaos exists at all levels of the universe, from the largest structures of galaxies to the smallest interactions between subatomic particles. The idea that chaos and order can coexist is not only a scientific concept, but also a deeply philosophical one. Philosophers have long grappled with the relationship between these two forces. Some, like Plato, believed that the universe was governed by ideal forms, abstract, perfect ideas that existed beyond the physical world, and that the material world was merely an imperfect reflection of these forms. Plato saw the search for order as an attempt to understand these ideal forms and their relationship to the physical world. Others, like Friedrich Nietzsche, embraced chaos as a necessary component of life and creativity. Nietzsche argued that chaos was not the absence of order, but a driving force for growth and transformation. According to Nietzsche, it is through the tension between chaos and order that new ideas and forms of life emerge. This philosophical tension between chaos and order also plays a significant role in human psychology. On an individual level, humans are constantly navigating the tension between the need for stability and the desire for change. The human mind seeks out patterns and structures that provide a sense of security and predictability. We create routines, institutions, and systems that help us navigate the complexities of life. However, we also need novelty, unpredictability, and chaos to grow and evolve. The ability to find balance between these forces is essential to our psychological well-being. It is through our interaction with chaos and order, both in the external world and within ourselves, that we experience growth, creativity, and personal transformation. In many ways, the pursuit of order in a chaotic universe reflects a deeper, existential need for meaning and understanding. The universe, with its vast complexity and seemingly random events, often appears to be beyond our comprehension. But through our intellectual, scientific, and philosophical efforts, we attempt to bring order to that chaos, to make sense of the seemingly random events that shape our lives and the world around us. Whether through the scientific search for natural laws, the philosophical inquiry into the nature of existence, or the personal quest for meaning in our own lives, the search for order is an essential part of the human experience. It is a journey that will continue as long as we strive to understand the universe and our place within it. This quest for order, however, is not without its challenges. As we delve deeper into the mysteries of the universe, we find that the more we understand, the more complex and unpredictable it becomes. The more we uncover, the more we realize that there is always more to discover, more to understand, and more to question. The universe, it seems, is infinitely complex, and every answer we find opens up new questions. Yet, it is in this ongoing pursuit, this search for order amidst chaos, that we find meaning and purpose. The tension between order and chaos drives human progress, both intellectually and personally. It is the very act of searching for understanding, even in the face of uncertainty, that makes the human experience so rich, meaningful, and full of potential. Whether in the realm of science, philosophy, or personal growth, the pursuit of order in a chaotic universe is an endeavor that defines our existence and will continue to shape our future for generations to come. As the search for order in a chaotic universe continues, humanity is often faced with a paradox. The more we understand about the universe, the more we realize that there are aspects of it that defy conventional understanding. From the earliest attempts by philosophers to make sense of the cosmos to the groundbreaking discoveries of modern science, our quest for knowledge has always been driven by the desire to uncover patterns and principles that govern existence. Yet, as our understanding has deepened, so too has our awareness of the inherent complexity and unpredictability that characterize the universe. The interplay between order and chaos is not only a central theme in scientific inquiry, but also one that shapes how we live our lives, make decisions, and understand our place in the cosmos. The idea that the universe operates according to both ordered laws and chaotic elements has profound implications for both our intellectual and emotional lives. On one level, the need for order is deeply psychological. Human beings, by nature, seek stability, predictability, and structure. Whether in the form of daily routines, societal systems, or personal belief systems, we create frameworks that provide us with a sense of security and control over our environment. Without these structures, life would feel chaotic and overwhelming. Yet, on the other hand, chaos is an essential part of the human experience. It is through uncertainty, unpredictability, and disorder that we encounter opportunities for growth, creativity, and change. This balance between order and chaos is evident in the development of human thought and scientific inquiry. Early philosophers, such as Pythagoras, Plato, and Aristotle, sought to impose order on the natural world by finding underlying principles that governed its behavior. Pythagoras, for example, believed that the universe was governed by mathematical principles, and he sought to uncover the harmony underlying all of existence. Plato's concept of ideal forms suggested that there was an inherent order in the universe that could be understood through reason and intellect. Aristotle, too, believed that the natural world could be understood through observation and reasoning, and he sought to categorize and systematize knowledge in order to explain the behavior of the physical world. These early efforts to bring order to the universe laid the foundation for the development of modern science. The scientific revolution, which began in the 16th century, marked a dramatic shift in how humans understood the cosmos. Pioneers such as Copernicus, Galileo, and Kepler challenged the geocentric view of the universe and proposed that the Earth orbited around the Sun. This heliocentric model revolutionized our understanding of the cosmos and demonstrated that the universe was not a fixed, immovable entity, but rather a dynamic, ever-changing system. Galileo's use of the telescope to observe celestial bodies revealed that the universe was full of mysteries waiting to be uncovered, and Kepler's laws of planetary motion demonstrated that the motion of planets could be described mathematically, offering a deeper understanding of the cosmos. Isaac Newton's laws of motion and universal gravitation, published in the 17th century, further solidified the idea of a deterministic universe governed by natural laws. Newton's laws provided a framework for understanding the motion of celestial bodies and objects on Earth, and his theory of gravitation demonstrated that the forces governing the movement of planets were the same forces that governed the motion of objects on Earth. Newton's work offered a sense of certainty and order to the universe, suggesting that if we knew the initial conditions of a system, we could predict its future behavior with accuracy. This deterministic view of the universe, in which every event was the inevitable result of prior causes, became the dominant paradigm in science for centuries. However, as the 19th and 20th centuries unfolded, new discoveries in physics began to challenge the classical view of the universe. Albert Einstein's theory of relativity, published in 1915, introduced a new understanding of space, time, and gravity. Einstein's theory showed that space and time were not fixed entities, as Newton had suggested, but rather were fluid and relative to the observer. This meant that the concepts of absolute time and space were illusions, and that the fabric of the universe could be influenced by the presence of mass and energy. The theory of relativity, which included the famous equation E=mc², revealed that matter and energy were interchangeable, and it provided a new understanding of gravity as the warping of space-time around massive objects. At the same time, the development of quantum mechanics introduced a new level of uncertainty to our understanding of the universe. Quantum mechanics describes the behavior of particles at the subatomic level, where classical laws of physics no longer apply. One of the key principles of quantum theory is Heisenberg's uncertainty principle, which states that it is impossible to simultaneously know both the position and momentum of a particle with perfect accuracy. This introduced an element of randomness into our understanding of the physical world, as it suggested that at the smallest scales of reality, events could not be predicted with certainty. The probabilistic nature of quantum mechanics contradicted the deterministic view of the universe that had been dominant in classical physics, raising profound questions about the nature of reality itself. The tension between order and chaos in the universe is not just a scientific or philosophical question, but one that also extends to the emotional and psychological realms. As individuals, we are constantly grappling with the balance between stability and change, certainty and uncertainty. On the one hand, we seek order in our lives, routine, structure, and predictability, which provide a sense of security and control. But we also face moments of chaos, whether in the form of personal challenges, unpredictable events, or existential questions that shake our sense of certainty. These moments of chaos can be unsettling, but they also present opportunities for growth, self-discovery, and transformation. The tension between order and chaos is not something to be resolved, but something to be navigated and embraced. The human capacity to adapt to both order and chaos is one of our greatest strengths. We create systems, social, political, and economic, that impose order on the world around us, ensuring stability and structure. At the same time, we develop the ability to adapt to the uncertainties of life, embracing change and uncertainty as opportunities for innovation and personal growth. This dual capacity for both order and chaos is what allows humanity to thrive in a world that is at once predictable and unpredictable, structured and chaotic. The scientific and philosophical exploration of the universe reflects this dual nature of existence. On one hand, science seeks to uncover the laws that govern the universe and impose order on the world. Through observation, experimentation, and theory, we uncover the patterns and principles that shape reality. On the other hand, science also reveals the limits of our understanding, showing that the universe is far more complex and unpredictable than we can ever fully comprehend. As our understanding deepens, we discover that even the most ordered systems are subject to uncertainty and randomness, and that the very forces that drive the universe are often beyond our control. In this context, the tension between order and chaos serves as a reminder of the complexity of existence. The search for meaning, understanding, and structure is a lifelong endeavor, one that is never fully complete. Whether in science, philosophy, or personal experience, the quest to navigate the balance between order and chaos is what drives human progress and shapes our understanding of the universe. It is through our embrace of both order and chaos that we come to understand the true nature of existence and our place within it. In the end, the search for order in a chaotic universe is not about finding definitive answers or creating a perfect system. It is about learning to navigate the uncertainty and unpredictability of life, while also embracing the moments of clarity and understanding that arise from our efforts to impose order on the world. The tension between order and chaos is not a problem to be solved, but a dynamic force that propels us forward, driving us to explore, to learn, and to grow. It is this tension that gives life its richness, complexity, and depth, and it is through our engagement with both order and chaos that we find meaning and purpose in a universe that is, at its core, both structured and unpredictable. The human mind has long been fascinated by the universe's structure and its seemingly random nature. We have an intrinsic desire to uncover the hidden order behind the chaotic appearance of reality. Our quest for understanding is not just intellectual but rooted in a deep psychological need for stability. In a world that often feels overwhelming and unpredictable, the search for order provides us with a sense of control and purpose. From the earliest civilizations, humans have looked at the stars and the world around them, seeking patterns that could explain the way things work. Early societies developed systems like astrology and astronomy, recognizing the predictable movements of celestial bodies and trying to apply that predictability to their own lives. Over time, this search for order has evolved into a more scientific approach. The works of ancient philosophers like Pythagoras and Plato laid the groundwork for a logical and structured way of thinking about the world. Plato's idea of ideal forms, where every object in the material world is a mere imitation of a perfect, abstract idea, suggested that the universe had an inherent order governed by ideal principles. Meanwhile, the Pythagoreans believed that numbers and mathematical relationships were key to understanding the universe, highlighting the role of mathematics as an essential tool for revealing underlying patterns in nature. The scientific revolution, which began in the 16th century, marked a major turning point in how humanity approached the question of order in the universe. Copernicus, Galileo, and Kepler shifted the understanding of the cosmos from a geocentric model to a heliocentric one, establishing that the Earth was not the center of the universe, This realization broke away from ancient beliefs, offering a new perspective on how celestial bodies moved and interacted. Galileo's use of the telescope revealed previously unseen aspects of the universe, further challenging traditional ideas. Kepler's laws of planetary motion demonstrated that planets moved in elliptical orbits, providing more precise predictions and laying the foundation for Newton's laws of motion and gravitation. Isaac Newton's laws of motion and universal gravitation were a milestone in the scientific understanding of order. His theories demonstrated that the movements of celestial bodies, as well as objects on Earth, followed consistent, predictable patterns. This determinism created a sense of certainty and clarity in understanding the physical world. Newton's laws applied universally, whether one was studying the fall of an apple or the orbit of a planet. His view of the universe, while vast and complex, was still governed by simple, fundamental laws that could explain and predict the behavior of objects across space and time. However, as scientific exploration deepened, new discoveries began to challenge the simplicity of Newtonian physics. The early 20th century brought about the advent of quantum mechanics and Einstein's theory of relativity, both of which introduced new complexities into our understanding of the universe. Einstein's theory of relativity proposed that space and time were not fixed entities, as Newton had described, but rather fluid dimensions that could be affected by the mass of objects. His famous equation, E equals mc squared, suggested that matter and energy were interchangeable, adding another layer to our comprehension of the universe's interconnectedness. In contrast to Newton's deterministic worldview, relativity showed that the fabric of the universe could bend and stretch, creating a more dynamic and flexible model of how reality functions. Simultaneously, quantum mechanics revealed a much more unpredictable side of the universe. Quantum theory suggests that at the smallest scales, particles do not behave according to fixed laws, but instead follow probabilistic patterns. The uncertainty principle, developed by Werner Heisenberg, shows that it is impossible to know both the position and the momentum of a particle simultaneously with absolute precision. This fundamental uncertainty undermined the deterministic view of the universe that had prevailed for centuries. While the larger world operated according to Newtonian mechanics, the subatomic world was governed by probability, where events could only be described in terms of likelihood rather than certainty. This shift to probabilistic thinking was a significant departure from the certainty offered by classical physics and suggested that randomness was an inherent part of the universe. Despite the unsettling implications of quantum mechanics, scientists did not abandon the search for order. Instead, they began to develop new models and frameworks to integrate both the certainty of classical physics and the uncertainty of quantum mechanics. The realization that the universe could be both ordered and chaotic at the same time sparked a reevaluation of how we perceive reality. Rather than seeing order and chaos as opposing forces, many thinkers and scientists began to understand them as complementary aspects of a unified system. The complexity of the universe, they realized, was not the result of an absence of order, but rather a different form of order, one that embraced uncertainty, fluidity, and change. The balance between order and chaos is also reflected in our personal lives and social structures. On a micro level, individuals crave predictability and routine, often organizing their lives around structured schedules and habits. This creates a sense of stability and control, which is essential for mental well-being. However, the chaos of life, unpredictable events, changes, and challenges often forces individuals to adapt and grow. It is in moments of uncertainty that people find opportunities for creativity, transformation, and resilience. The tension between these forces shapes not only our intellectual understanding of the universe but also our capacity to navigate life's challenges. Socially, the need for order is reflected in the institutions and systems humans create. Governments, legal systems, and educational frameworks are all attempts to impose structure on society, ensuring that people can live together in a way that minimizes chaos. However, these systems are not static. They evolve and change as societies grow and encounter new challenges. Just as the scientific theories of order must adapt to new discoveries, social systems must also remain flexible to accommodate the complexities of a changing world. The interplay between stability and change, tradition and innovation, is a driving force in both scientific discovery and societal progress. The search for order in a chaotic universe, whether on the grand scale of the cosmos or the personal scale of human experience, is an ongoing journey. While we may never fully understand the intricacies of the universe, it is the pursuit itself that provides meaning. Every discovery, every breakthrough, and every moment of clarity adds a new layer to our understanding of the world. Yet, as we continue to unravel the mysteries of existence, we must also accept that chaos is an inevitable part of the process. It is through the combination of order and chaos, through our ability to find patterns in randomness and to embrace uncertainty, that we gain a deeper understanding of the universe and our place within it. The tension between these forces does not signify a failure to understand. Rather, it is the very essence of human exploration and growth. The concept of order in a chaotic universe has been a central theme in human thought for centuries. It encompasses our desire to understand the world around us, to find patterns and meaning in the seemingly random events of life. From the earliest observations of the stars to the latest discoveries in quantum mechanics, humanity's quest for order has shaped our understanding of the cosmos and our place within it. This drive to make sense of the universe reflects a deep psychological need to impose structure on a world that often feels unpredictable and uncontrollable. In the early stages of human history, the first attempts to understand the world were based on observations of the natural world. Ancient cultures, particularly those involved in agriculture, began to notice patterns in nature that seemed to offer some semblance of order. They observed the cycles of the moon, the movement of the stars, and the changing seasons. These observations allowed them to predict the best times for planting crops, for harvesting, and for various other activities crucial to survival. These early astronomical studies were humanity's first attempts to impose order on the natural world, seeking patterns in the behavior of celestial bodies, and applying that knowledge to the rhythms of everyday life. This need for understanding the universe through recognizable patterns led to the development of early forms of calendars and astronomical charts. As societies progressed, the intellectual approach to the question of order in the universe evolved from mere observation to more formalized systems of thinking. Ancient Greek philosophers such as Pythagoras, Plato, and Aristotle contributed significantly to this shift. Pythagoras, for example, believed that the universe could be understood through mathematical relationships and that numbers were the key to unlocking the mysteries of the cosmos. He saw mathematical principles, such as the harmony of numbers, as an inherent part of the universe's design. Plato, similarly, introduced the idea of ideal forms, abstract concepts that existed beyond the physical world but governed the reality that humans experienced. For Plato, the pursuit of order in the universe was an attempt to understand these perfect forms and their relationship to the material world. Aristotle, on the other hand, sought to provide a systematic way of understanding nature. He believed that the universe was governed by natural laws that could be discovered through reason and observation. Aristotle's empirical approach laid the groundwork for the scientific method, where observations about the natural world lead to the formulation of general principles and laws. While his understanding of the universe was limited by the technology and knowledge available at the time, his efforts to create a logical framework for understanding the natural world were foundational for the development of later scientific thought. The scientific revolution, beginning in the 16th century, marked a crucial turning point in humanity's search for order. This period saw a shift from philosophical speculation to empirical, observational science. The work of Copernicus, Galileo, and Kepler fundamentally changed the way humans viewed the cosmos. Copernicus's heliocentric model, which proposed that the Earth orbited around the Sun, challenged the long-held belief that the Earth was at the center of the universe. Galileo's use of the telescope to observe celestial bodies revealed new details about the Moon, the stars, and the planets, expanding our understanding of the heavens. Kepler's laws of planetary motion provided a more precise description of how planets moved, showing that they followed elliptical, rather than circular, orbits. Newton's laws of motion and universal gravitation, published in the late 17th century, offered a powerful explanation for how objects in the universe move and interact. Newton's work provided a sense of predictability and order to the universe, suggesting that all objects, from the smallest particles to the largest celestial bodies, followed the same fundamental laws of physics. Newton's law of universal gravitation, which stated that every mass in the universe attracts every other mass with a force proportional to the product of their masses and inversely proportional to the square of the distance between them, explained the motion of planets, the behavior of tides, and the fall of objects to the ground. Newton's universe was one of mechanical determinism, where every event followed from prior causes, providing a clear and ordered framework for understanding the natural world. However, in the 20th century, the advent of quantum mechanics and Einstein's theory of relativity introduced new complexities into our understanding of the universe. Einstein's theory of relativity showed that space and time were not absolute, as Newton had believed, but instead were relative to the observer. His famous equation, E equals mc squared, revealed that energy and mass were interchangeable, fundamentally altering our understanding of the relationship between matter and energy. Relativity also demonstrated that gravity was not a force transmitted through space, as Newton had proposed, but rather the warping of space-time caused by massive objects. These discoveries introduced a more dynamic and fluid conception of the universe, one that could not be fully described by the deterministic laws of classical physics. At the same time, quantum mechanics challenged the very idea of determinism. Quantum theory, which describes the behavior of particles at the smallest scales, revealed a universe where uncertainty and probability were central. Heisenberg's uncertainty principle, for example, suggested that it was impossible to know both the position and momentum of a particle with perfect accuracy. In the quantum world, particles did not behave predictably, and their behavior could only be described in terms of probabilities rather than certainties. This introduced a new kind of order, one that was probabilistic rather than deterministic, where the universe could not be fully predicted but instead followed statistical laws. Quantum mechanics revealed that the universe, at its most fundamental level, was not a mechanical machine operating according to rigid laws, but a complex system where randomness and uncertainty played an essential role. The tension between order and chaos, between determinism and uncertainty, is central to our understanding of the universe. The early, mechanistic view of the universe suggested that everything was governed by fixed laws that could be discovered and understood. Yet the discoveries of modern physics have shown that the universe operates on multiple levels, with both deterministic and probabilistic laws governing the behavior of matter and energy. The apparent chaos of quantum mechanics and the flexibility of space and time in relativity point to a universe that is far more complex than previously imagined. Despite the challenges posed by the discovery of uncertainty and the unpredictable nature of the quantum world, the search for order continues. Scientists, philosophers, and W2C thinkers have come to understand that chaos and order are not opposing forces but complementary aspects of the universe. The randomness of the quantum world does not negate the search for order, but rather expands it into new realms of understanding. The more we learn about the universe, the more we realize that the quest for order is not about finding absolute certainty, but about uncovering the patterns and principles that govern the behavior of matter, energy, and space. It is through the interplay of order and chaos that the universe becomes a dynamic, evolving system, full of complexity and beauty, where discovery and growth emerge from the tension between these two forces. In the end, the pursuit of understanding the universe is not about finding definitive answers, but about embracing the mystery and complexity that make the universe so fascinating. It is the very tension between order and chaos, certainty and uncertainty, that drives us forward in our intellectual and personal pursuits. Through this balance, we continue to evolve, both as individuals and as a species, seeking meaning and understanding in a universe that is both predictable and unpredictable, ordered and chaotic. The search for order in a chaotic universe is an ongoing journey, one that will continue to shape the way we understand reality and our place within it for generations to come. The human mind has always been fascinated by the idea of an ordered universe. Since ancient times, people have gazed at the stars, observed the cycles of nature, and sought to understand the deeper truths behind the apparent chaos of the world. The desire to impose structure on the universe is not just an intellectual pursuit, but a psychological need, one that has driven countless generations to search for patterns and laws that govern the world. At the heart of this search is the belief that beneath the randomness and unpredictability of life, there lies a deeper order waiting to be discovered. In the early stages of human civilization, the search for order was primarily based on observation. Ancient peoples observed the movements of the sun, the moon, and the stars, and realized that these celestial bodies followed certain patterns. These patterns allowed them to create calendars and systems to predict the changing of seasons, the timing of crops, and the cycles of the moon. This early observation of the natural world was humanity's first attempt to find structure in the universe. Over time, these observations expanded to include not just celestial bodies, but also the natural phenomena on Earth, like the flow of rivers, the growth of plants, and the migration of animals. Ancient philosophers also sought to impose order on the universe. Figures like Pythagoras, Plato, and Aristotle developed frameworks for understanding the world around them. Pythagoras believed that numbers were the key to understanding the universe. He thought that the world could be understood through mathematical relationships, and that harmony could be found in the numbers that govern nature. Plato, similarly, believed in the existence of ideal forms, abstract concepts that existed beyond the material world and which governed the reality humans experienced. For Plato, the pursuit of order was an intellectual search to understand these perfect, abstract forms. Aristotle, on the other hand, was one of the first to formalize the study of nature in a systematic way. He believed that the universe was governed by natural laws that could be discovered through observation and reason. He classified various aspects of nature, such as animals, plants, and even the movements of celestial bodies, into categories, seeking to identify patterns in the natural world. Aristotle's approach laid the foundation for later scientific inquiry, though it was still limited by the knowledge and tools available at the time. As humanity's understanding of the universe progressed, the scientific revolution of the 16th and 17th centuries marked a dramatic shift in the way humans approached the problem of order. The work of Copernicus, Galileo, and Kepler revolutionized the understanding of the cosmos. Copernicus's heliocentric theory proposed that the Earth orbited the Sun rather than the other way around, challenging the ancient geocentric model that had placed the Earth at the center of the universe. Galileo's use of the telescope allowed him to observe celestial bodies in unprecedented detail, leading to groundbreaking discoveries about the moons of Jupiter and the surface of the Moon. Kepler's laws of planetary motion provided a more accurate understanding of how planets moved, showing that they followed elliptical orbits rather than perfect circles. The work of Isaac Newton in the late 17th century brought a sense of definitive order to the universe. His laws of motion and universal gravitation offered a comprehensive framework for understanding the movement of objects both on Earth and in the cosmos. Newton's laws suggested that all objects, from the smallest particles to the largest celestial bodies, followed the same fundamental rules. This understanding provided a sense of stability and predictability to the universe, with Newton's laws acting as the foundation for classical mechanics. His work demonstrated that the universe was not a chaotic, random place, but one governed by fixed, predictable laws that could be studied, understood, and applied. However, as humanity's understanding of the universe deepened, new discoveries began to challenge the classical view of the cosmos. The 20th century brought with it revolutionary ideas that disrupted the sense of order humanity had come to depend on. Albert Einstein's theory of relativity, published in 1915, demonstrated that space and time were not fixed but rather relative to the observer. His famous equation, E equals mc squared, revealed the interchangeability of energy and matter, fundamentally altering the way scientists thought about the relationship between these two quantities. Einstein's theory of relativity showed that gravity was not a force that acted at a distance, as Newton had suggested, but rather the result of the curvature of spacetime caused by massive objects. This theory introduced a new understanding of gravity and space, showing that the universe was more dynamic and flexible than previously thought. At the same time, quantum mechanics introduced a level of unpredictability to our understanding of the universe. Quantum theory, which describes the behavior of particles at the subatomic level, revealed that the universe was not governed by fixed laws in the way Newton had imagined. Instead, particles behaved in probabilistic ways, meaning that their behavior could only be predicted in terms of likelihood rather than certainty. The uncertainty principle, developed by Werner Heisenberg, stated that it was impossible to simultaneously measure both the position and momentum of a particle with absolute precision. This introduced a level of randomness and uncertainty to the universe, showing that at the smallest scales, the universe operated according to probabilities rather than certainties. Despite the introduction of uncertainty, the quest for order did not stop. Instead, scientists sought to understand how this new probabilistic order could fit into the broader framework of the universe. The dual nature of the universe, where both deterministic laws and probabilistic behaviors coexist, challenged our understanding of reality. This new view of the universe suggested that while some aspects of the cosmos could be predicted with certainty, others were inherently uncertain, and both of these elements were crucial to understanding the full scope of the universe. The tension between order and chaos extends beyond the realm of science and into the human experience. On a personal level, individuals seek order in their lives through routine, structure, and predictability. This need for order is rooted in a desire for stability and control over one's environment. However, life is inherently unpredictable, and moments of chaos, whether in the form of personal challenges, unexpected events, or existential questions, often force individuals to adapt and grow. It is in these moments of chaos that creativity, innovation, and personal growth emerge. The ability to navigate the balance between order and chaos is essential for human resilience, growth, and transformation. The interplay between order and chaos is not confined to individual lives but extends to the social and cultural structures humans create. Societies are built on systems of laws, institutions, and norms that provide structure and stability. These systems help reduce the uncertainty and unpredictability that come with human interactions. However, just as scientific theories evolve in response to new discoveries, social systems must also adapt to changing circumstances. As new challenges arise, these systems are reshaped to accommodate the complexities of a changing world. The ability of societies to balance order and chaos, to adapt while maintaining a sense of stability, is a crucial element in their survival and growth. In conclusion, the search for order in a chaotic universe is an ongoing journey that is shaped by both intellectual and psychological forces. From the ancient philosophers to modern scientists, humanity's quest to understand the cosmos has been driven by the belief that there is an inherent order to the universe. While the discoveries of modern physics have revealed the complexity and unpredictability of the universe, they have also deepened our understanding of the patterns and principles that govern reality. The tension between order and chaos, determinism and uncertainty, remains central to our understanding of the universe and our place within it. Whether in the realm of science, philosophy, or personal growth, the quest for order continues to shape our world, driving us to explore, understand, and adapt to the ever-evolving nature of reality. Throughout history, humanity has consistently sought to impose order on the seemingly chaotic universe. This search for order is not merely an intellectual exercise, but a deeply ingrained psychological need to make sense of the world. From the earliest civilizations, humans have looked at the stars and natural patterns to try to uncover laws and principles that could explain the workings of the cosmos. As our understanding deepens, we realize that the universe is not only unpredictable, but that within this chaos lies a complex structure governed by fundamental forces. The earliest forms of understanding the universe were rooted in observation and intuition. Ancient societies, particularly those involved in agriculture, were keen observers of the natural world. They noticed patterns in the behavior of celestial bodies and the changing of seasons. These patterns, although observed without a deep scientific understanding, provided the foundation for early calendars and systems of timekeeping. This need to organize time and events based on natural cycles was humanity's first attempt to bring structure to what otherwise appeared to be an unpredictable world. Early astronomers and navigators used the constellations to guide their paths, laying the groundwork for the scientific exploration that would follow. As civilizations advanced, thinkers such as the ancient Greeks introduced more structured ways of understanding the universe. Philosophers like Pythagoras and Plato believed that the universe was governed by mathematical principles and ideal forms. Pythagoras, for instance, argued that the world could be understood through numbers, and the harmony found in the relationships of these numbers reflected the underlying order of nature. Plato, on the other hand, suggested that the physical world was merely a reflection of perfect, abstract, ideal forms that existed in a higher, metaphysical plane. This idea suggested that the physical world, while seemingly chaotic and imperfect, followed a deeper, rational order dictated by these ideal forms. Aristotle, another foundational figure in Western thought, took a more empirical approach, trying to understand the physical world through observation and categorization. His work in biology, physics, and metaphysics laid the foundations for centuries of scientific inquiry. He believed that everything in the natural world had a purpose or function, a concept that later influenced the development of scientific thought in the Western tradition. Aristotle's influence persisted long after his death, especially in the medieval period, where his ideas shaped how people viewed the cosmos and the natural world. In his view, the world was governed by natural laws that could be discovered and understood by human reason, a sentiment that would dominate scientific thought until the early modern period. The rise of modern science during the Renaissance and the Enlightenment marked a significant shift in humanity's approach to understanding the universe. The works of Copernicus, Galileo, and Kepler fundamentally altered the way we viewed the cosmos. Copernicus proposed the heliocentric model, placing the Sun at the center of the solar system, challenging the geocentric model that had been accepted for centuries. Galileo's use of the telescope revealed new details about the night sky, confirming that celestial bodies did not adhere to the Earth-centered model. Kepler, through careful observation, formulated laws of planetary motion, showing that planets followed elliptical orbits rather than perfect circles. These revolutionary discoveries shifted the foundation of human understanding, suggesting that the universe was not a chaotic, disorderly place, but one that followed rules and patterns that could be understood through reason, observation. The crowning achievement in classical physics came with Isaac Newton, whose laws of motion and theory of gravitation provided a comprehensive framework for understanding the physical universe. Newton's insight into the nature of forces and motion revealed a universe that could be predicted and understood with mathematical precision. Newton's laws of motion, which described the relationship between the forces acting on an object and its motion, and his law of universal gravitation, which explained how objects are attracted to one another, provided a sense of control over the natural world. Newton's universe was one where every action had a predictable reaction, and where celestial and terrestrial bodies followed the same set of physical laws. However, in the 20th century, new discoveries began to challenge the deterministic view of the universe that Newton had set forth. The development of quantum mechanics and Albert Einstein's theory of relativity upended the traditional understanding of the universe. Einstein's theory of relativity proposed that space and time were not fixed but were instead relative to the observer and could be influenced by the presence of mass. This showed that gravity was not a force acting at a distance but rather the result of the curvature of space-time caused by massive objects. While this theory explained large-scale phenomena, quantum mechanics revealed an even more fundamental challenge to the notion of a predictable universe. Quantum mechanics introduced a new kind of uncertainty into the scientific worldview. At the smallest scales of reality, particles behave in ways that defy classical physics. The famous uncertainty principle, formulated by Werner Heisenberg, stated that it is impossible to know both the position and momentum of a particle with perfect accuracy at the same time. This uncertainty suggested that, at the quantum level, the universe could not be fully predicted, rather, it operated on probabilities. Quantum theory introduced randomness as an inherent feature of the universe, challenging the deterministic view that had dominated physics for centuries. Despite these challenges, the quest for order in the universe did not end with the advent of quantum mechanics and relativity. Instead, these theories expanded our understanding of the universe by revealing that chaos and order are not opposing forces but complementary aspects of the same system. The universe is governed by both predictable laws, such as the laws of physics that describe the motion of objects, and by probabilistic rules, such as those that govern quantum particles. This duality suggests that while we may never fully understand all aspects of the universe, there are still patterns and principles at play that we can study and understand. Moreover, the search for order in a chaotic universe extends beyond the realm of science and into the human experience. On a personal level, individuals often seek order in their lives by establishing routines, creating structure, and finding meaning in their daily actions. Societies, too, create systems of laws, customs, and organizations to impose order on the collective human experience. These systems are designed to reduce uncertainty and help people navigate the complexities of life. However, just as scientific theories must evolve in response to new discoveries, social systems must also adapt to changing circumstances. The ability to maintain a balance between order and chaos in both our personal and collective lives is essential for progress and stability. The tension between order and chaos is what drives human creativity and growth. While order provides stability and security, it is often in moments of chaos, when we are faced with uncertainty and unpredictability, that we are forced to innovate, adapt, and grow. Whether in science, philosophy, or daily life, the search for meaning and structure in the universe is not only about finding answers, but also about embracing the challenges that come with uncertainty. This balance between order and chaos shapes how we experience the world and how we evolve as individuals and societies. It is through the tension between these forces that we continue to explore the mysteries of the universe and our place within it,